Welcome to the Explainer. Today, we're embarking on a cosmic quest, leaving our solar system behind to hunt for planets orbiting other stars.
You know, it really all boils down to this one fundamental question. It's a question that has driven astronomers for centuries, and right now, it has absolutely exploded into one of the most exciting fields in all of science.
So here's our roadmap for this journey. We'll kick things off with the basics, look at the clever ways we find these planets, then zoom in on the hunt for life, take a tour of some truly bizarre discoveries, and finally, peek into the future of the search. Okay, let's start at the beginning. What exactly are we looking for out there, and how's the search going so far?
The definition is beautifully simple. An exoplanet is any planet that orbits a star that isn't our sun. But don't let that simplicity fool you. This concept has completely revolutionized how we see the galaxy. I mean, before the 1990s, this stuff was pure science fiction. Now, it's scientific fact.
And here are the results. We've confirmed nearly 6,000 exoplanets. That's across more than 4,000 star systems. It's an absolutely staggering number, and it's growing almost every single day. What's really incredible is just how young this field of astronomy is. The very first exoplanets, they weren't found until 1992, and they were circling a pulsar, the dead, spinning corpse of a star, a totally hostile environment. But it was the discovery in 1995 that really opened the floodgates. And boy, did that discovery shatter our expectations. 51 Pegasi b introduced us to a whole new type of planet, the hot Jupiter. This thing is a gas giant, way bigger than Earth, but it orbits its star in just 4 days, roasting at 1,000 degrees Celsius. It was nothing like anyone expected.
So that begs the question, how in the world do you find a tiny, dark planet from light years away when it's totally lost in the glare of its star? Well, it takes some seriously clever detective work.
If you look at the data, it's amazing. One method just completely dominates the field. While there are a few ways to spot a planet, more than 3/4 of every single discovery has been made using something called the transit method. And the concept behind this method is so elegant. Basically, you stare at a star, and you wait. You're watching for a tiny, repeating dip in its light. That little dip tells you a planet might be passing in front of it, causing a mini eclipse. It's like spotting a mosquito flying in front of a spotlight from 100 miles away. Finding thousands of planets is a monumental achievement. For sure, but for a lot of us, the real prize, the whole point of the search, is to find a world that could actually host life.
To do that, the search zeroes in on this orbital sweet spot, the habitable zone. You probably know it as the Goldilocks zone. It's that perfect distance from a star where it's not too hot, not too cold, but just right for liquid water to exist. And where there's water, there might be life.
But here's the catch. That zone isn't in the same place for every star. For a big, hot star, the habitable zone is way out. But for a small, cool red dwarf, a planet would have to huddle in real close to stay warm enough.
And this helps us narrow the search even more. Giant stars, they burn out too fast for complex life to evolve. Red dwarfs, they can blast their planets with deadly flares and lock them in place, with one side scorching and the other frozen. So our safest bet, our best chance, is to look for planets orbiting stars just like our own sun.
Okay, now for the really fun part. The universe is way more creative and strange than we ever could have imagined. Let's take a quick tour of some of the most bizarre and wonderful worlds we've actually found.
First up, meet what some people call Earth's cousin, Kepler 452b. It's a rocky world, it's in the habitable zone of a sun-like star, but it's a super-Earth, much bigger and older than our planet. So it's close, but definitely not a twin. Then you get the truly weird ones. This is Kepler 7b, a gas giant that's so low in density, it's been compared to styrofoam. I'm not kidding. If you could somehow find a bathtub big enough for it, this entire planet would float. For all you sci-fi fans out there, reality has delivered. This is Kepler 16b, a real-life planet that orbits 2 stars. So if you were standing on its surface, yep, you would get to see a double sunset every evening. And from the spectacle of 2 suns, we go to a world of almost complete darkness. TREES 2b is the darkest exoplanet ever found. It's a gas giant that absorbs nearly all the light that hits it, making it pitch black, darker than fresh asphalt.
These discoveries are incredible, but they're just the beginning. The next chapter in this story is already being written by a new generation of powerful telescopes. So, what's next?
The next great leap isn't just finding planets, it's studying them. By analyzing the starlight that filters through a planet's atmosphere, we can look for the chemical fingerprints of life, what we call biosignatures. And if we find both oxygen and methane together, well, that would be a profound discovery.
And we've got the tools for the job. The Kepler telescope was the great surveyor. It found thousands of candidates. Now the James Webb Space Telescope is starting to analyze their atmospheres. And even more powerful telescopes are already being planned for the decades to come, designed specifically for this search.
But you know, this cosmic search also acts like a mirror. As we scour thousands of star systems, this whole journey reminds us that worlds like ours, rich with resources and overflowing with life, are not easy to find. They are precious and maybe exceptionally rare.
And that leaves us with one final, profound thought. As we look out into that vast cosmic ocean, we have to be prepared for both possibilities. What it would mean to find life, and what it would mean if, after all this searching, we don't.